Hi dear students, welcome to my class. This is for 10th students. Okay, the chapter is acid, base and salts. In the last class we are completed the acid and bases. In this class I am going to explain about salts. Okay ma. So in the last class we have discussed about the importance of pH. In that pH we see the multiple importances of pH. So in this class we have some general knowledge purpose questions. That is, I am going to discuss in the your page number 28. We have a tab table, that is some naturally occurring salts. Naturally occurring salts. It is very useful for the competitive exams for police. Teachers, like some competitive exams, so these are very important. So the natural source, one is a natural source, the next column is acid, and next natural source, next column is acid. So from the vinegars we can observe the acetic acid. Vinegar, the acid is acetic acid. From oranges is there now. From that orange fruit, so citric acid is present. Tamarind. In tamarind, tartaric acid is present, and in tomato oxalic acid is present, and then milk or curd, in lactic acid is present, in lemon citric acid is present, in ant sting methanoic or methanoic acid, and nettle sting methanoic acids. These are the some useful information about these acids. Okay, Nama. In this class, the first, before going to the salts, I have to discuss some questions in the your textbook exercise questions, page number 28. See, you have two solutions. You have two solutions, A and B. You have two solutions, A and B. We have two solutions, A and B. The pH of solution A is 6 pH. pH is 6, and B is 8. B is 8. From this, which solution has more hydrogen ion concentration? More hydrogen concentration in between A and B. Which one is more hydrogen ion concentration? So we have compared to A and B, A as a minimum number or minimum value, lower value, higher hydrogen ion concentration. That's why this is high concentration of H plus ions, hydrogen ions. The next question is which this is acidic and which one is basic. So I already told about the pH scale 0 to 7 and 14. Here 0 to 14 the total pH scale, from 0 to 6.9 acidic and 7.1 to 14 basic. So A is acidic. A is acidic in nature. A is acidic in nature, and B is number 8 now. That's why this is basic in nature. Basic in nature. Okay, Nama? This is all about first question. So the next question is what effect does the concentration of hydrogen ions, that means in aqueous hydrogen ions have on the nature of the solutions? Now we have one beaker. In this beaker we have one solution. Okay, now is a solution, that is we call as A. A is a type of solutions. In this they told what effect does the concentration of hydrogen ions on this nature of the solutions. If hydrogen ions are more, we call as we call as acidic in nature. That type of effect of hydrogen ions means if hydrogen ions are more, we call as this is acidic in nature. Okay, Mama? The next, do basic solutions also has H plus ions? They are asking the questions. Basic solutions means they contain OH minus ion. Right now. So production of acids produces H plus ions, bases produces OH minus ions. The question is carefully observe, do basic solutions also have H plus ions? If yes, then why these are basics? So listen carefully. Of course, bases has H plus ions. Bases has H plus ions. Why? Because when compared to H plus ion and OH minus ion, H plus ion and OH minus ion, the OH minus ion concentration is high. High concentration. High concentration. That's why we call as they are basic. They are basic. Right, Amma? So for the first question, do basics also has H plus ions? Yes. Bases has H plus ions. Then why they are basic? Because of high OH minus concentration. High OH minus ions concentration. That's why they are basics. Okay, now the fourth question. Under what soil condition do you think a farmer would treat the soils of his fields with a quick lime, that is calcium oxide, slacked lime, that means calcium hydroxide, or chalk? So if the farmer's soil is in acidic, if soil is acidic in nature, this is not good for the agriculture. If soil is in acidic nature, not good for agriculture. Right now. So when the pH is below 5.5 5.2 7, below 5.2, we call it that soil is a acidic soil. When the pH is 5.5 to 7, then only we use this calcium hydroxide, slacked lime, or some more slacked lime, calcium quick lime, and chalk we are using to neutralize the soil, neutralize the acidic soil. Thus exactly good soil for the pH value is that is 7, nearly 6 to 7 is good, 6 to 7 or 7.5. This is the best pH for the agriculture. When soils are acidic nature, then only we add our farmer adds the slacked lime, quick lime, and chalk. Okay, this is all about your exercise questions. Now we have to move on to the more about salts. More about salts. We are already discussed how salts are formed. How salts are formed in the previous sections. That means reaction of metals and acids. Metals and acids. Metals reacts with acid, or acid reacts with metals, it gives salt and hydrogen gas, right? And reaction of acid and base, it gives salt and water. And also acids reacts with the metal oxides, they are also produces salt. Acid plus metal oxides produces salts and hydrogen gas. So these are the way to produce the salts. Okay, Rama, these are way to produce the salts. So this is all about production or preparation of salt. So we have an activity. So that activity is 2.13. In that we have some salts name. So we have to write the chemical formulas for these salts. The first one is potassium sulfate. K2SO4. Potassium sulfate. Next is sodium sulfate. Na2SO4. Sodium sulfate. Calcium sulfate. CaSO4, Ca plus, this is minus 2. That's why Ca2SO4. Ca2SO4. Next is magnesium sulfate, MgSO4. MgSO4. Magnesium sulfate, Mg plus 2, SO4 minus 2, balance. That's why MgSO4. Next is copper sulfate, CuSO4. CuSO4. Next is sodium chloride, NaCl. Sodium chloride, NaCl. Next is sodium nitrate, NaNO3. NaNO3. Na plus, so this is minus 2 right now. So Na2NO3. Na2NO3. Next is ammonium chloride, NH4Cl. NH4Cl. Right now, these are some salts. These are some salts of chemical formula. In this, we have to identify the acids and bases from which of the above salts may be obtained. This is very, very important. How can you identify positive ion and negative ions? That means cations and anions. Cations and anions. From this K2SO4, K2SO4, K plus SO4 minus 2, SO4 minus 2 from K2SO4. Next, Na plus SO4 minus 2, crisscross method. Next is Ca plus and SO4 minus 2. Next, Mg plus and SO4, Mg2 plus and SO4 minus 2. Next is Cu plus 2 and SO4 minus 2. Next, Na plus Cl minus. Next is Na plus NO3 minus, NH4 plus and Cl minus. These are the ions, K plus SO4 minus 2 ions. This is potassium ion, this is sulfate ion, sodium ion and sulfate ion, calcium ion, sulfate ion, magnesium ion, sulfate ion, copper ion, sulfate ion, sodium ion, chloride ion, sodium ion and nitrate ion, ammonium ion and chloride ion. This is the ions. So you have to remember, please remember, all cations means positive charged ions. Positive charged ions we call as basic radicals. Basic radicals. What is this basic radicals? I already told this. The generally salts are formed by the acid base reaction. Acid base reactions, right? So from the acid radicals and basic radicals, salts are obtained. In this is a compound. Potassium sulfate is a salt. This salt is made by a acid radical and a basic radical. Here acid radical is sulfate and basic radical is potassium. K plus positive charge indicates basic radicals, negative charge indicates acid radical. This is very, very important. Please remember. Okay, Rama? So next is salts having the same positive and negative radicals are said to be belongs to a family, same charge, like sulfates. This is 1, 2, 3, 4. This is a sulfates family, sulfate family. Next, sulfate. This is 5. These 5s are a sulfate family. And next, here sodium sulfate and sodium chloride and sodium nitrate. These are sodium family, right? Same charges, Na plus, same charges. Positive, it may be positive or negative. Here negative, I am taking negative charges. SO4 minus 2, sulfate family. These are NaSO4, NaCl and NaNO3 minus, these are sodium family. Next is chlorine. This is NaCl and NH4Cl. This is chloride family. Chloride family. Like that, we have to naming the ions. Next is and salts having the same right now. And for the example, NaCl. Some gives the example NaCl and Na2SO4, sodium sulfate. Here, sorry, this is Na2SO4. Here also I written Na2. I forgot here. Okay. Sorry, this is NaSO4. Right. This is right. So because crisscross here 2 is right. So Na2SO4, Na2SO4, Na2. So Na plus this Na and this is Na. So on decomposition, this is Na plus and Cl minus. NaCl on decomposition we get sodium ion and chlorine ion. In this sodium sulfate. Yes, here sodium sulfate Na plus and SO4 minus 2. Here also sodium ion and here also NaCl sodium ion. That's why this is sodium family. Okay, Rama. This is all about family of salts. This is all about family of salts. In the next class, we are deeply discussing about the pH of salts and chemical form of salts, common salts right now. So you have to remember the salts are obtained from the generally acid-base reactions. That means a salt is made by acid radical and basic radicals. This is form we call a single salts. Double salts are also there. Okay, Nama. This is all about salts. Okay. In the next class, we will discuss deeply of salts. Okay. Thank you.